These are the notes on rigid transformations from section 6.1. So first, a brief definition of rigid transformations. There are two important pieces to this definition. Rigid, meaning the object does not change their shape or size, and transformation, meaning movement. So rigid transformations move objects within the plane, but do not change their shape or size. There are three rigid transformations. The first one we're going to look at is called translation. So the definition. Translation is a transformation that slides every point in the plane the same distance and direction. So there are a couple of different ways that this is formally written, and we're not going to get into that at this point. You'll see those in subsequent notes. But one way to think about it is if I had this triangle, and I'll name it ABC, and I translate it, slide it, and I can slide it in any direction and any distance. So I could slide it over just a little bit or a lot. I could slide it over at an angle. I could slide it over at an angle this way. I could slide it backwards. Any kind of slide that is happening. So let's slide this over along this vector. So we'll put our new B right here. And we have a direction. We're moving straight horizontal, and we have a distance, 1, 2, 3, 4, 5, 6, 7. Excuse me, so I slid B over 7, which means I need to slide A over 7. 1, 2, 3, 4, 5, 6, 7. And C over 7. 1, 2, 3, 4, 5, 6, 7. And now I have to name this new triangle. And we name them by using this lovely symbol that looks like an apostrophe, but it actually is named prime. So A prime, B prime, C prime. And we call this first triangle the pre-image, and the second triangle the image. And we'll talk about those definitions in a little bit more briefly. Our second rigid transformation is known as reflection. Reflection is a transformation that reflects or mirrors, flips the plane over a line. So let's look again at our lovely triangle. We'll use the same general shape. Call this one NAG. And for a reflection, in the translation, we're told the direction and how far. In a reflection, we need to have a line that we're reflecting it over. So let's have our line, in this case, be this line. So I need, if you can imagine, taking the triangle NAG and flipping it over this line. So some interesting things happen. For instance, A is going to be, our new A prime, is going to be the same distance from our line L. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, rename that A prime. And that will be true of N and G. So N is 1, 2, 3, 4, 5, 6, 7 from line L. So we're going to go 1, 2, 3, 4, 5, 6, 7. And then G is 1, 2, 3, 4. So we'll go 1, 2, 3, 4. And I've now reflected the triangle NAG over line L. And again, we call this figure the pre-image, and this figure the image. Remember, our definition in both of these cases talks about sliding every point, reflecting every point, but something really interesting happens in terms of the points that I see getting reflected are the ones that I have pointed out. So everything on this side gets reflected over here and vice versa. It's just that the ones that I've pointed out are the ones that we really can see. So they are the points N, A, G. My third rigid transformation is rotation. And rotation is a transformation that rotates or turns all the points in the plane around a point by a certain number of degrees. So again, we're talking about the whole plane, every single point we see. It's just that we're going to use the points that we name in order to really see this rotation happening, this transformation happening. Doing a transformation freehand is a lot more messy than what we could do with the translation and the reflection. So you just bear with me in terms of the fact that this is going to be kind of a rough sketch. So I have this lovely triangle. We'll call it ATN. And I'm going to rotate it around this point. We'll call it O, 90 degrees. So again, just bear with me in terms of the fact that this is going to be a little bit more hand-wavy since we haven't done this in a formal way yet. And so you're just going to have to kind of trust me right now that it will end up being the correct rotation even though it's not something that you have formally seen. So, this is where N prime ends up, which means this is where A prime ends up. I've got my N prime kind of in a funky place right now, which means then this is where T prime ends up. And this is a 90-degree rotation around O. Let's go back and just kind of annotate some of this a little bit. We've already annotated up here the pre-image and image. We'll do that down here also. This is the pre-image. And this is the image. So to be a little more formal in our definitions here, let's give a definition for these two words.